everybody hear me all right? Great. So I'm going to talk about Deploylib, which is a component of the RAD Lab stack that's targeted to be the interface between either humans or computers and the data center. So this is a pretty well-populated space out there. And this is one of the RAD Lab's efforts to contribute to the space based on the lessons we learned about the declarative data center, which is one of our original goals. So I'll tell you some of the motivation behind it, which we're calling anti-patterns, which were inspirations for learning from the mistakes people make and that we make in managing data centers. Remind you of our original vision for the declarative data center, and then show you how we fulfill that, or try to, with Deploylib. So in 2009, Michael told you about, he introduced Deploylib then, a very early version of it, and told you about, he called the anti-patterns were grad student anti-patterns at that time. And they were things that grad students do when running experiments at large scale on clusters. And we, since then, as we've grown Deploylib, have realized that the things that grad students do aren't all that different from the things that typical developers who work with clusters and operations people who work with clusters do when it comes to just getting things to work. And so we generalized the anti-patterns to be just cluster management anti-patterns. So one that we have in common is that the state of the cluster should never, but almost always, be on the nodes themselves implicitly, which means that you go in and you change a configuration file because something's not working right now. And then when that node fails, the node that comes up to replace it doesn't have that small change you made. Not a earth-shaking problem, but it's something that happens all the time. An instance of this happening, before I move on, an anecdote is that I myself, when doing the Hadoop patch before we had Deploylib with Mate, was compelled to leave on 10 nodes, EC2 nodes, for a weekend because it took me long enough to install Hadoop on those nodes on the Friday that I was working on it, that I didn't want to take them down so that I would have to bring them back up on Monday and reinstall Hadoop. Don't tell Dave that I did that. Another example of things that people do is that they use scripts that are often shell scripts written that call other shell scripts. And while this is great, the failures often are transient and are unreported and or partially reported. And we see examples of this in Mesos, where we wrote shell scripts, or we even wrote Python scripts that SSH into machines try to do things. And oftentimes, you'll say, please launch 10 Mesos nodes on EC2 for me, and only 8 will come up. And it won't tell you that. The RAD Lab, throughout the duration of the project, has had each grad student use a separate EC2 account to do their research. And that's great, but in the cloud sharing cluster of the future, we foresee people wanting to share the pool, wanting to pool their resources and run multiple services at the same time on the same cluster, even if it's in EC2. So what we're migrating towards, and what this demo is a first demonstration of, is everybody's projects running using the same shared pool of nodes at an abstracted level. And Deploylib enables this sort of thing. And finally, as a grad student, we think that the problem of wanting to run multiple repeatable tests of the performance of something is not unique to us. We think that people in industry want to do this as well, and anybody who works with the data center. So being able to run repeatable experiments where you're not configuring, running, and then trying to remember which experiment results went with which graph is also an anti-pattern we want to learn from. So to address this situation, we propose that the data center should have a high-level language for deploying and managing services. To fulfill that declarative data center vision, we built Deploylib, which is a DSL that extends Scala. So we're taking advantage of all of the features of Scala Scala is a high-level productivity language that compiles down into Java bytecode and runs on the JVM. So we get to leverage the JVM, a lot of JVM tools and the ecosystem around the JVM. And we also get to leverage the functional aspects of Scala, which is perfect for working with lists, and in our case, lists of nodes. We have strongly typed access in Scala to objects that represent operations and components of the data center. And we have, these are, examples of these would be ls or create a file. You can access the data center programmatically, which with one of the visions of the RAD Lab being machine learning algorithms to do a lot of the data center control was an important thing to us. And you can also drop into a console at any time and use tab completion and whatever you like in the Scala console to access the same objects. Deploylib abstracts away whether you're running locally, whether you're running on your local private cluster, or whether you're running on EC2, such that you can use the same sort of functionality between all of these things. And it also leverages the exceptions that you see, like in Java or Scala, to make errors a much more integrated aspect of dealing with failures and service management in the data center. So Deploylib is two major modes of operation. I'll talk first about the low-level service management, and then the high level, and I'll try and give a little interactive demo of each. So the low level, the idea here is that instead of keeping lists around that maybe you write a shell for loop over to go and SSH into a machine or all of your machines and update a configuration file or something, you use Deploylib to manage the SSHing for you. And you can access, you can script the process of then managing the nodes in your data center all at once. The key features that we thought were important were being able to do this in parallel. And we were able to naturally extend, for instance, the map function to be a pmap, and the filter function to be a pfilter inside of Scala to parallelize these operations over the nodes. And should be idempotent, so that if you do a create file, it does the right things underneath the covers, such that we can do that more than once and you're not causing problems. All right, so fingers crossed, this is not a highly tested demo. So what I'm doing now is I'm SSHing into one of our nodes in our data center. All right. So I've built Deploylib, and I'm going to drop into the Deploylib console. I'm going to load some necessary libraries. So I'm using tab completion as I go. Now, so first let's demonstrate the kind of seamless integration between working locally, or between, let's say, working on the R cluster. So let's see what's in here for R cluster. R cluster dot. Let's see what happens if we just look at our cluster. So I'm going to assign it to an object and I'm going to cheat a little and use the history in the Scala console to look at some of the things I can do on this. So let's say we wanted to look at the active nodes in the R cluster. It's going to SSH underneath the covers into those nodes, make sure that they're where I expect them to be, and then hopefully give me a list in Scala back. That's not very readable. So let's try for each print line. And maybe this will add some new lines for me. All right, so these are the host names. What if I wanted just one of these? So I got R1. And now I want to see what can I do with R1. Well, I can create a directory on it. I can ls a directory. I can, let's see if we do JPS. List the Java processes running on it. All right, so looks like we have one Java process running on. Now, let's say I wanted, instead of working with the R cluster, to work with EC2. So we have a very parallel class, EC2.instance, that we can say active instances, just like we looked at the active nodes in the R cluster. So this is now using my personal EC2 credentials, not Michael's. Michael's running the demo, which is running several hundred nodes. I'm running 5 nodes just for my demo purposes. And I want, let's say, let's leave that actually. And do, so one of the problems we see often when we're managing EC2 nodes is seeing the public DNS versus a private DNS. So a thing that we do frequently is map dot public DNS name. And now we can see all of the public DNS names. We can just as easily say something like private DNS name and see the internal names. Let me see if there's anything else I wanted to say. All right, so another thing managing low-level services we probably want to do is set up Mesos on that cluster. So what we can do is now have this another layer of abstraction where we've added functionality to manage something more complicated than just running ls or exec this command for me and show me the output. Where I can say, for instance, start masters, and I can tell it to start 5 masters if I want. So I can do this. It'll take 5 minutes to bring up the EC2 node and actually run it. So I'm not going to run that command. I did run it earlier in order to bring up these 5 nodes that I'm working on. I actually ran 1 master and 5 slaves. So I can also do add slaves and give it a number of slaves to run. I can look at should be able to look at the slaves and see that I'm running, in fact, 5 slaves. And I can look at the first Mesos slave. And do some Mesos-specific thing, like enable monitoring, or and also this is interleaving now the Mesos operations that I can perform on this with all of the other EC2 operations that I can perform on it. And this is the sort of ls things that I can do on any node. Let me just see. Show you my notes. This line. This is impossible. First master includes the string. Test. Fixed? Yeah, I'm running it. Oh, yeah, you can see, right? So oh, that's not good. But the problem with this is that, so what I did is I said Mesos first master. So I grabbed the first Mesos master. It said run this, bang, question mark, says run this and show me the response. And it said make dir mount test t. Problem with this is that, and it probably told me in here somewhere, the actual error, which I can catch with an exception, thankfully, and now notice is that the mount test doesn't actually exist. So if I add a -p to this, it returns nothing because, and does not throw an exception, because now it actually created that directory by adding the parent. So the fact that it threw that exception is exactly what it should have done. And as you can see, I planned that. But I forgot that I planned it, which is the benefit of not practicing your demos. All right, so now let's talk quickly. Yeah. Mm-hmm.
You were the guy who did the programming.
Yeah. So the question for the recording was, why would we want to, or is it okay to throw these exceptions for Elvis users who might not know how to handle these exceptions? Is that about right? Or wouldn't it be better to give them much more friendly messages with these exceptions? So the idea is somebody using Deploylib, the philosophy behind it, to write this, to extend Scala with these specific sort of operations would wrap the low-level mode. So the low-level mode is not for Elvis, what I'm showing you now. It's for somebody actually who writes the high-level layer, which I'll get to next. And the high-level layer will have caught these exceptions and given you more friendly error messages. So high-level service management, basically, if you can envision wanting to do things with the nodes now, like run Mesos, keep track of the sort of messages you should expect to get from Mesos, and give me simple one-button operations at the console or to use in a web interface that let me do useful things, like launch a service. For instance, if I wanted to launch scatter or launch gradit, I'd like to have one command. And maybe I'd like to stack those all together and have one command that says runDemo. And in fact, we have a runDemo command, which works. I'm not going to show it to you, so you'll have to believe me. But that's the idea with being able to stack these things and abstract away the complexities at each layer so that you have Elvis at the right layer and the end users at the higher layers. The advantage of Scala and Deploylib in this sort of space is that now you've got users who are using Deploylib to write services on the cluster, and they have dependencies on a bunch of other services. Like gradit uses scads, but also runs on top of Mesos as a web application that gets its resources from Mesos. Scads gets its resources from Mesos. And so the gradit application actually has dependencies on both Mesos and scads. And what you would like is the person who's using it not to have to manage all these dependencies, and the people who built Scala and Java, who they inherit from all the principles of dependency management apply. So we use simple build tool, which takes care of all of, you need these jars, and this thing needs those jars. A lot like Maven, if you've used that. And the cool thing about Deploylib is that it's integrated with simple build tool, so that when I write a scads app, all of the necessary jars automatically get uploaded to the cluster when I deploy, because it's part of the package management is integrated. And that goes with the next step, or the next point here, which is when I run my code, I can test it all locally. I can actually run the whole demo stack on my laptop. And it will fire off the C++ binaries, which are not part of the build tool, by the way. So there's one thing that we haven't gotten to yet. But it'll actually run a local Mesos master, slave, and zookeeper, and the whole stack all on my single laptop. it will keep track of which binaries have been rebuilt and modified and only upload ones based on your typical timestamps and MD5 hashing. And it will let you, because of that sort of caching, and we keep everything in S3, for instance, all of your jars are in S3, timestamped and MD5 hashed, such that with that metadata, we can roll back. If I made a change and I saw some bug, I can roll back the actively running scatter to the previous jar. And by the way, the Ruby on Rails apps are compiled down into JRuby and run in the JVM as well. And like I think Amr was asking about, the information at the low-level library is abstracted away nicely for people who are using the higher-level services. And finally, we have type-safe service configuration. We use Avro. And Avro gives us the ability to make it so that the flags we pass to our tasks on each node, the separate little Jetty web server that needs to run to serve our Ruby on Rails app, which has been wrapped in Java. So it's a complicated thing. We need to say, use a Java heap of this size, or make sure that that this task gets launched with this. It's a very typical thing in cluster management platforms like this. Ours, instead of passing strings around, which almost every other tool we know of does, lets you marshal into well-typed objects and unmarshal on the other side so that everything is type safe in your configuration management from your console and from the person who's writing the app. So now this one is going to be more just showing you the function names because each of them takes a considerable amount of time. But if I do a start, this is actually how we run the demo that you see today. The first thing we would do is we'd we would do like a EC2, a Mesos dot start masters. We'd add slaves, and then we'd start starting other services. So we would start a meta scheduler, and then we'd start scatter, and we'd start credit, and we'd start the directors. And in the end, we would run demo if we wanted to just have one command that would do everything for us. And this might be overloaded so that we can optionally say which AMI instance I want to use. If I'm trying out a new AMI that I've built Mesos on in a different way, for instance. Or it can optionally let us control the size of the demo and all the other sort of parameters that you'd want to use. So that's Deploylib. And it is, in fact, the thing that is running all of the demo that you see today. And that's it for me, and I'll take questions. Yeah. So also, Michael Armbrust is the primary author of Deploylib. So he will help with questions if necessary.
So one thing I didn't see in your demo, I was wondering if your library and language help support this, is your language seemed very powerful. You could make a large number of changes to all your machines simultaneously and quickly. What if that's the scariest thing you know possibly how to do, and you'd rather have a slow canary process followed by a staged rollout? Does your language have features or support that allow you to understand all of the rollouts that are going simultaneously?
We haven't. So I would say that the architecture of the language is such that you would use the low level, which is essentially something like an administrator having passwordless sudo on every node, right? Like you can do the same damage with a shell script. I think that we'd argue that you should have at the lowest layer, that first layer I talked about, the control to do that, and then you should write the second layer that you're asking whether it exists, and the answer is not really right now. Okay. Because all of us who have been working at this level on the project are slightly above Elvis, we would think maybe slightly above Elvis level. So that's why it doesn't exist yet. But we think somebody should write it. Is that right, Michael?
Yeah, I think basically what it comes down to is those low-level actions, we would generally use them to compose these kind of higher-level services. So an example where Andy showed it was this like Mesos EC2, and I think that is a much safer system to use than the other one. And But still, you kind of want that low-level control, so we give that to you. But I agree with you. When you're actually running a production cluster, you'd use that very sparingly.
So I would actually argue from experience that sometimes it's useful to have your lowest levels be speed limited in themselves.
I see.
Mistakes by programmers at the upper levels
Don't
take the entire problem.
Okay, yeah, that's good feedback. Do you have a question or?
So I'm assuming that the time that it takes to set up these scripts was not counted towards like the 18 hours of app development time. So how long did it take to set up these scripts?
That question.
Yeah.
So it took a substantial amount of time to kind of get the infrastructure in place. Adding the third app, though, I think Beth also helped, but I would say 5-10 minutes at most to do the third app once all the infrastructure was in place. So yeah, pretty simple. But there was, substantial building of the stuff to launch web servers and all of that stuff earlier on. But once that stuff was in place, pretty quick.
I have a question on one of the things we do is move application from cluster to cluster. So let's say you start on a software cluster, you want to move it to EC2 or back or somewhere else, and that's a really hairy process. Is it conceivable to build a test suite with your system on top of a mock set of applications and run a trial run before you actually do the real thing? Because it seems really cool, except when things go wrong, then your whole site goes down.
Yeah, I think it's one of the stated purposes is to be able to bring up 100 EC2 nodes with an arbitrary app, which, maybe in less than 18 hours you add a new web app to your current code base. You push it out to EC2 and run it with Rain, which is what's generating our workload for today. I think one of our visions is that the demo you see today is a test environment for web developers to bring up and test. I don't know, does that answer your question?
And just to add to that is basically how the demo is architected. You can run multiple versions, and then there's one command that you run, update load balancers, that actually takes your current cluster live. So, you can run multiple iterations. You could bring it up on EC2 or in a different zone, test it out kind of manually, or have some kind of automated testing, and then there's one command that would switch the load balancers to point to your new cluster and make it live.
So one thing we haven't done we haven't spent a lot of time debugging yet is the launch it on the R cluster, which I showed you a little of, and then launch the same app on EC2. So I think that's possible, but that would be another major thing that's still on our to-do list. Was that going to address them? Yeah.
How are failures handled? If I try to execute an operation against 1,000 nodes, say, and 50 of them failed, what happens?
Yeah, and so I'd turn it back and say, what do you think should happen? Like right now, what happens in our Mesos scripts, for instance, is either the script, actually what does happen is the script just sits there because that one node never reported back. And eventually it times out and it dies and it never moves beyond that one of the 1,000 nodes that we launched that never actually came up. And so all of the rest of the script, which sets up NFS and everything else, never gets to run.
But I would just add to that to say that for all of the parallel operations, we actually have two modes. We have a synchronous mode where everything kind of blocks, and if there's a failure, it'll throw an exception. And there's an asynchronous mode where instead of running synchronously, you get futures back for all of the operations that you run on the cluster. And so what you can do then is you can go and inspect those futures and decide what to do with the failure cases. So, I think it's application dependent what you do when there's a failure. Do you try it again? Do you try it on another machine or whatever? But that is kind of something that we tried to support when we were designing Deploylib.
What about asynchronous failures? Suppose things just die below you.
So, I would assume that anything that's going to kind of fail asynchronously, you're going to run on top of Mesos. And the Deploylib Mesos service running architecture does have support for then shipping the error back to wherever you specify in that case. Yeah, so one more question, and then we're going to move on so that we stay on schedule.
Yeah, definitely feel free to come up and talk to us offline about this.
So, Apache has a project called WHIRR, WHIRR, which tries to do this same thing, and it has support for multiple clouds, EC2, Rackspace, vClouds from VMware, et cetera, et cetera. So just curious, what's the difference? Did you try and contrast between Deploylib and WHIRR?
So I'm not familiar with WHIRR.
Okay.
Deploylib, actually, I kind of just started as I was running experiments and needed something to kind of automate it a little bit, and then it grew from there. But I'll definitely take a look at that and see.
Yeah, we've heard of WHIRR, and we're definitely going to be talking to you all, the Were folks. I think when we started Deploylib and got on the path, I don't think Were was around at that time yet. I think a lot of the functionality that we've added recently duplicates Were, and maybe that's a bad thing, or a good thing, and we should learn from each other.